Hey everybody, Dave Lindbergh in Liberty Lake, Washington today. We're going to do a tutorial on the ZUMI headphone test and measurement system today for you because we're going to be showing it at CES. So we're going to be in the Alti Suite next week. So if you see this before then, come see us in the Venetian Hotel in room Lido 3101B, or now that we can go into China, if you want us to come to your factory or whatever, contact us when we're back in Hong Kong after Chinese New Year. So anyways, any time for that. So Simon's in Japan. Good morning, Simon. How are you?
Good morning. Very, very good. Very good.
Yeah, you look like you just rolled out of bed. So great for
That could be true. That may well be true.
All right. So yeah, what we wanted to do here is kind of run through people out of the box. How do they going to use this to test their headphones? So yeah, just let's get in on it.
We'll start with a simple case, and what I'll do is measure a few different Bluetooth headphones in a kind of a getting a feel for it mode, let's say. So it's not strictly following a pattern of measuring all the different aspects and applying some limits. I just want to get a curve and see what it looks like. So I've got the tester here, and on it at the moment is actually one of these Sony XM5s, I think that one is.
Right.
And then you'll see on the larger display is the host application or companion application. So just want to emphasize one point. This is totally standalone test device. The host application does no processing at all. It's just there to display the graphics for us and give us an additional user input option through a PC in this case.
Okay.
So we'll crack into it, and so I can use this, in fact. So we'll start the test. And for a Bluetooth headphone, first thing you need to do is get the Bluetooth connected. So when I start the test, the ZUMI test is going to look for an available Bluetooth device. When it finds one, connect to it. You can modify those a little bit to say, find all the available devices and choose the strongest, or just show me and let me choose which one. But most of the time, you're just going to set it up with choose the first one that you find. Because in a lot of environments, you know what you're doing, right? So you've set it up that
yeah.
you don't want any random thing.
So in a production environment, it would be polling to find the closest one. So basically, an operator picks it up off the line and sticks it on, and then when it moves along, how does it disconnect? Is there a function they have to do to disconnect it from the Bluetooth, or it will
yeah, so you have two choices, well, a couple of choices. One is you can say automatically disconnect when I've finished a test, or don't do that. You might want to repeat the test several times. You don't need to reconnect, in which case you just power off the headphone, close the connection, and it will reset to looking for a new one.
Good. Okay,
so here's the frequency response from XM5, and you see it's just repeating over and over. If I bump on the cup, I'm going to see I'm injecting massive noise, and we get a lot of rubbish in there. So we'll just leave that steady for a minute. And
this is the Sony, sorry, the XM.
Yeah, this is the Sony, and interesting. There's actually quite a bit of difference for this level of headphones. Quite a bit of difference between left and right. Now, I suspect that actually this is one that I've played around with already, kind of. Had a look inside, pulled the ear pads off. So it may not be assembled very well. I doubt that Sony will be putting out products with this much difference.
Okay.
At that price level, say at under $100 or $50 headphones, that's not so bad. You won't really hear that, but it's not quite at the level, so we can see that. And I'm going to stop that 1 second, just do one other thing and modify the configuration. So I'm putting in a fairly low level. Let me put in a high signal level. And the reason I want to change the signal level is to get better signal to noise ratio. If you're in a very quiet thing or an anechoic box, a low spectrum, then you don't need to worry too much about that. But in an open setting like this, if I'm using a very low signal level, the sound from my voice will actually start showing up in the measurement. And if you're watching, we kind of saw that with a bit of spikiness in this 200 to 500 range. Okay, interesting one there from the Sony. Now I increased the level, and but it didn't change the position of this curve overall because we're calculating the frequency response. So that means the sound that you get out divided by the sound you put in. If you put in a small level, you get a small level out. And so the ratio remains the same, theoretically, right? As long as everything's pretty good.
Mm-hmm.
And so that's y-axis is showing us the SPL, in this case, per 0 dBFS, because we're running through the Bluetooth. If we're running through a cabled thing, it would be per dB volt.
Okay.
Per 0 dB volts. And of course, the frequency on the x-axis. Down here, we've got RMS. And this RMS is actually a calculation of the EN50332 standard.
Okay.
And this loudness of a headphones concept.
It's
people were using. Go ahead. Yeah.
It's root mean square, isn't that?
It is. That means root mean squared, but it's just shorthand because you need to say root mean square of what or in what context. So you can do it a couple of various different ways. You can take the signal and just calculate the root mean square, or you can use this method of EN50332 where you put in place like a simulated program audio, which is pink noise, and you apply a weighting and you apply another correction to it to get that. So it's not, you won't get the same number depending on how you do it. Just to point out that this is, we should call it an estimate, because strictly speaking, if you're doing that standard, you put it onto you play this pink noise and you repeat 5 times, calculating this thing. But we're able to calculate that directly from the frequency response, and it is. In theory, it's exactly the same thing, but we should still call it an estimate.
Okay.
Okay, good. But of course, that will depend on the volume setting on the headphone. I haven't checked that, if it's at maximum or not. Doesn't matter at this moment. Just point that out. Okay, good. Well, let's try another headphone for comparison's sake. So I can just leave that running. I'll power this one off. Yep. Who's next? This Sennheiser model. These are all, kind of the top Bluetooth ANC headphones, actually, that from the various companies. So I powered off the.
I was just going to say we'll put the model numbers in the description below so people can see.
Yeah, well, we don't need to too picky about it. So I just powered off the Sony, and it's in a repeating measurement. As I say, we're just having to play around to look at the curves and see how things compare, and we can talk a bit more about what that actually means.
Okay.
So it's just in a repeating loop, making this measurement, showing us the result. I just powered off the Sony while it was connected, and then what happened is the ZUMI found I lost my connection. I just want to get another connection. So then I power on the Sennheiser, put it into pairing mode, and it connects to that one, and away we go.
Okay.
Jiggle that around a little bit. And what I did is I put a hold curve or freeze those curves on that Sony, which become the dim line background, just to make a visual comparison between that and the Sennheiser on one graph.
Right.
So that's interesting. And, one of the challenges of trying to get a good headphone sound is to how do you use this data is actually the question, because there's no direct correspondence to say, I see, that sounds better than that, because it's really just a squiggly line. If you're in the space of speakers, usually say it should be a ruler flat line across the page. That would be perfect. But with headphones, you just can't mimic the same conditions, because you have to have a kind of a HATS, an ear canal simulator, et cetera, et cetera. So you always end up with a lot of crazy resonances. And that's what really happens when you listen to it. But subjectively, you don't feel like that's the case necessarily. Some people will say otherwise, but those things are there. So it's really hard to pick out what part of that is important, what part of the curve is important, and what isn't. Pause that for a minute. And especially when you're looking at this range over 2 kilohertz, you're basically seeing a lot of spikes, up and downs. And so you say, well, what does any of that mean? And you can actually pick through that and say, okay, well, I've got certain characteristics that are reasonably common between the two headphones. Let's say around this 4K region, this kind of a bump here that's apparent in both. And so that may be a characteristic of the ear system itself, that it doesn't matter what headphone you put on there, you're going to see this effect to some degree. And then we have another sort of, peak dip thing right around the 6K hertz. And they kind of both have some indication that exists to some degree. But you might say, well, it looks as though the Sennheiser is a bit lower in amplitude than the Sony. And again, when we get to very high frequencies, over 10K, we might say, it looks as though the Sennheiser has got quite a bit more level. So what's our scale? We're actually at 10 dB per line. I'll zoom it in a little bit. So yeah, we're getting close to 7.5 dB. So it's quite a significant increase in the very high frequency range. So people might think that's nicer. Let's say that's brighter or sharper. Pretty high frequency, though. Not many people will be, well, no, that's still in the range that you'll get a sensation from it. So carry on, let's try something else. That one's still connected. I'll disconnect that. I need to power it off. This one doesn't like to power off quickly. Or at all. There we go, finally. Maybe. Did it? Yes, it did. Let's try this BOSE. I think it's QC45 next.
Okay.
That went into pairing mode. Quite a long delay. I'm not sure if I should give up and try again. I'll give up and try again. There we go. That looks like pairing mode. Good, and it's connecting. BOSE does a lot of telling you the name of the Bluetooth device, so it takes a while before you actually get a signal out.
Okay.
I can hear I don't know if you can hear that. There's like a strange noise, a chirp coming out of that one. That's kind of curious. I wonder if it's some kind of a, we're driving too much signal into it and it's doing a kind of a compression or a clipping. Let me take the level down a little bit, say, and just try that again. Yes, that's interesting. So just now we were driving pretty much full scale signal into it, and I could hear that BOSE headphone was making a click noise, or it had a strange noise. It might pick it up on the microphone, I'm not sure. Okay. And so I took the level down and that's all gone, and then the low frequency response is responding normally. So I thought that's kind of interesting. Maybe they have some protection against too much input signal, which would otherwise cause a distortion.
Okay.
I hadn't noticed that before. Okay, so there's some of the frequency responses that we're going to get. So let's just run through it one more time, and I'll collect a curve set for each one. In fact, one more thing to just point out, I'll start that again, is in the low frequency range, we're always fairly stable because the wavelengths are very long. It doesn't matter too much where you place the ear cup. So what I'll do is move this ear cup. Actually, I'll freeze that curve. I'll move the ear cup kind of forward and let it settle. And what we can see is that in the low frequency range, I got a bad story there with some noise, but it doesn't matter. In the low frequency range, we more or less don't change very much. But as we get into the higher frequencies, you see these peaks and dips move around quite a lot, actually. So it does make it difficult to make a definitive statement about the high frequency response, because you have to take into account, how the ear cup's positioned and so on. So what should you do about that? Well, one obvious answer is to apply a lot of smoothing. So you eliminate the effect of these peaks and dips and kind of get an average level through that range. So maybe we should do that. And we'll put in reasonably strong smoothing. See how that looks. Still seeing that. Now let me get it set up nicely, and we'll use like quite a high, a fair bit of smoothing, and compare all four headphones. Curious about that, actually. There's always going to be a bit of differences between left and right channels, but here we go. Okay, good. That's the BOSE one. So when we put the smoothing up, that's great. You get kind of a more, let's say, visually useful curve.
Right.
But you have to be careful you're not throwing away important information about what the headphone is doing. So it's often worthwhile to take a look at it in both modes, smoothed and unsmoothed, I mean. And there's the Sennheiser. So I think when we're using the high level of smoothing, it's easier to see where the differences between the headphones lie, actually, isn't it? Because you kind of take out a lot of the jaggedness, and you can start to say, well, Sennheiser has more bass than the low frequency output is higher. And right around this range of sort of 1K to 4K seems to be a relatively large dip there that the BOSE doesn't have. And what's interesting is, to my ear, when I listen to both of them, I find that the BOSE is too forward in that range. So it sounds kind of telephony. It's got that real voice level is very pronounced, whereas the Sennheiser is a lot more laid back. And I actually find that better, and that might be something that people would set up as a target to say, well, you might look at it and say, the BOSE is very flat. Isn't that better? Because they're getting very close to this flat line once we've smoothed everything out, of course, across the range. Shouldn't that be better? Well, not necessarily. It may actually be that just because of the way the hearing system is working and the way that you're measuring it, in fact, you don't want so much level right in that range, and that might sound a lot better, easier to listen to. I'll go back to the Sony. Need to power these things on and off. Maybe I should set auto disconnect next time. Start that running. Fairly similar characteristic in the low frequency for the Sennheiser. In fact, overall, it's quite similar, actually, isn't it? I didn't store that Sennheiser, but if we just imagine back, still seeing that difference between channels in the low frequency and this point here. I suspect that's me having sort of not assembled it as well as it could be.
Right, okay.
I've mentioned one other thing, actually. Each time I finish a test, so we'll start again. When I start the test, it's in a looping mode, and so it's indicated because we're flashing here to say it's waiting for us to give further input. I'll press the button to complete that mode. It finishes the test, and all this, every time I finish a test, that data is stored, so we can go back and have a look at it.
Right.
I have one more headphone that better not leave you out, because this B&W unit.
Oh. The P7, is that the model?
PX7 or P7, yeah.
Okay.
Cancel the Sony, put that one in place. And away we go. Takes a few seconds to complete the connection. And there we go, slightly different style. It's kind of looks a bit more like what they talk about with a Harman curve, where you the low frequency kind of steps down into the mid range around this, possibly a little bit high here at 400 hertz. They usually have it around 200 or 300 hertz. Again, they've got this kind of notchingness right around there that the others do. Great. So stop that one. I didn't capture the BOSE the first time around, so I'm just going to repeat that measurement quickly. Didn't capture it in the sense that I left the test looping. I didn't stop it, so it never actually got to the point of logging that data.
Oh, okay.
When you're doing it in a production environment, you'll always get to the end of a test sequence and get your logs. If people are worried about that, you can disable the log, of course. It's on by default, just so we capture everything. And we can go back and have a look at the data and do some analysis, and we'll just do that quickly. Do this one. There we go. But the BOSE takes a little while to get going. Okay, well, we had the BOSE there previously, so we just get the same curve back.
Right.
But this time I'll let the test complete. And we were looking at, excuse all of this, got a whole bunch of, what I'm doing is selecting a test profile that I've been using and this data analysis tool through the host application. And I'll just sort by date, and we'll take the most recent 4, which will be those graphs that we've just been looking at. And we can compare those like this. Rather than making too much of an explanation, let me just have a play around. I'll choose this trim curves tool. Actually, let me see the legend. I'm going to chop off all the lefts. There's too many curves. It's hard to see what's going on. Trim out the left there as the yellow one there, just so we get a comparison of the 4 by themselves. And the left is this, that guy there. There we go. So we know from memory, I don't know if you remember, this one is actually the BOSE. And they're actually kind of a bit different than everybody else. Everybody else is really getting quite a similar general characteristic that is sloping down from, say, 100 hertz pretty much continuously till you get to this point around 2 kilohertz, and then you get a step up, and then the high frequency region is, in general terms, relatively even across here. So you might argue whether you want to have that slightly higher or lower, perhaps. So there we have it, a simple way to make a comparison between a few different headphones. Still left the challenge to decide what you prefer, what you'd like as a characteristic function. Right. But you've got this kind of easy way to just get a feel for what others are doing, let's say, and make a comparison of those. So we might pick out one and say, I think that this, was it? No, it might have been that one. One of these two is the Sennheiser. I think it's this one, isn't it? No, it's going to be this one. It's going to be this guy here. See, the Sony and the Sennheiser are very similar overall characteristic. The BOSE and WILKINS going a bit heavier on the bass and dipping in this kind of mid-range a little bit, which a lot of people really like. Actually gives you a more, I don't know, openness, I guess, to the sound. Some bass emphasis. So good. I think that's all I wanted to just show in this instance. Yeah.
Cool. All right. Well, we're well, I'm on the road, so I've got all kinds of funny lights going on. So apologize to people for that. But yeah, anybody, please reach out to us if you want to see this at CES, or actually anytime going forward. If you catch this video after CES is over, we're always available to set people up with a demo or answer your questions to see if it's the right fit for your benchmarking or production testing or all kinds of utilities. So I think that's good for today. Anything else you'd like to add, Simon?
No, it's good. It's good. Maybe we can try to do a few more of these little things. fairly short, and look at a few, one or two different aspects.
Sure. Okay. All right.
Thanks.
So thanks for your time today, Simon, and like, subscribe, and all that good stuff below, everybody. Thank you. Bye-bye.